Hello everyone, welcome back to my Chem Corner. So in today's video we're going to talk about calculations involving unit cell dimensions. So here with whatever information that we have learned so far in this entire chapter, we're going to find out a formula to calculate density and problems related to it. So before we move into the video, if you're new to the channel, please subscribe to the channel and hit the bell icon so you receive notifications as and when I upload a new video. So let's move into the video. So here we're going to look at calculations involving unit cell dimensions. So basic things, we're just going to take out all the information from the previous videos that we learned and we're going to find out the formula. So for this we need the volume of the unit cell formula, which is nothing but A cube. Now the mass of the unit cell is going to involve how many atoms are there in that unit cell that's belonging to it. So if we're talking about a simple cube, only one atom belongs to the simple cube. And if you're looking at a body-centered cube, there are only two atoms that belonging to a body-centered cube. And if you're looking at a face-centered cube, there are four atoms belonging to it. And these numbers you get from a calculation that we did in the previous videos. If you haven't seen that, or if you haven't watched that video, I will put the link in the description box and you can just go through that video so you know what I'm talking about. Now, into mass of each atom. So that is the formula of mass of a unit cell. So here, mass of an atom present in a unit cell is equal to molar mass by Avogadro number. So here we have the formula. Small m, which is the mass of the atom, which is equal to capital M, which is generally given for molar mass, by Avogadro's number. Now from this, when we try to write on the formula of density, the general formula for density is mass by volume. So mass of the unit cell is given here, number of atoms in a unit cell, which is given as Z, into mass of each atom. Mass of each atom is given here, which is capital M by Na. So when we substitute the entire thing, mass of the unit cell is equal to Z, which is the number of atoms per unit cell, into molar mass divided by Avogadro number into volume of the unit cell, and the denominator is going to be A cube. So this is going to be the final formula that we are going to use to calculate the density when we have other values given to us. Now, before we move into the problems, whenever we do problems related to this, the values of these edge length will either be in two parameters. One is in nanometer, second one is in picometer. But we never calculate them directly. We never use these conversions directly. Instead, we need to show some conversion to centimeter or meter. So I'll show you what those conversions are. So when we have 1 nanometer, when we convert it to meter, it's going to be 10 to the power minus 9. Further, when you convert it to centimeter, which is normally the unit that you use in the calculation of a density, it's going to be 10 to the power minus 7 centimeter. So this is going to be the conversion when you move from nanometer to centimeter or nanometer to meter. Now another unit that can be mentioned in the problem is picometer. Now picometer, 1 picometer is equal to 10 to the power minus 12 meters, or it is equal to 10 to the power minus 10 centimeter. So these are the two units that are generally mentioned in a problem on density of this type. So you are all expected to know these conversions, because in the end, what answer you get has to be in terms of gram per centimeter cube for a density. So your conversion here is very important. So kindly use these conversions, kindly learn these conversions when you're going to solve problems related to density. So now let's move into the problem. So here the first problem is silver forms an FCC lattice and X-ray study of its crystal show that edge length of its unit cell is 408.6 picometer. Calculate the density of silver whose atomic mass is 107.9. So here, these are the few informations given to us in the question. Let's put that down in the problem, in the solution, so that we are not confused when we try to substitute it. So let's write what is given to us in the question. First thing is A is given to us. A is nothing but edge length. Edge length is given to us as 408.6 picometer. Now I told that we will not use this picometer directly in the problem. Instead, we need to show its conversion. So we will convert it to centimeter. So 408.6 picometer, when you convert it to centimeter, is going to be 408.6, 10 to the power minus 10 centimeter. I've just shown meter here, so you know what the conversion looks like, but centimeter alone is more than enough. So now in this, when we write down this value in terms of centimeter, this is the value you're going to use in the substitution and further calculation. Now next one, what is given to us in the question is atomic mass of silver, 107.9 U. Now the next value that is not given but should be understood is in the first sentence here. Silver forms FCC lattice. Now the minute you know that this particular crystal is of an FCC lattice, the number of atoms per unit cell for an FCC is 4. Therefore, Z is equal to 4. So we know what is A, we know what is M, we know what is Z. And Na, which is the Avogadro's number, is a constant value, 6.022, 10 to the power 23. That should be known by heart. So we have all the values. Now we just need to substitute it in the formula and calculate the density. So we have Z value, we have M value, we have A value, which has to be cubed, and we have Na, which is a constant. Now the next one is we will just substitute it directly. Now when we substitute, Z is equal to 4 into molar mass divided by, we need to cube this entire A value along with the power into the Avogadro's number. So first what you will do in the calculation is you need to cube this and then do your further calculation. Now when you solve this completely, your answer here is going to be 10.55 gram per centimeter cube. So this is going to be your value for this particular problem. Now the next question is problem number 2. An element forms a BCC crystal. The unit cell edge length is 260 picometer. Calculate the density when the molar mass of the element is 23 gram per mole. Similar type of a question, but instead of having it as FCC, we have a BCC crystal here. So let's see what is given to us in the question. Similar type of values. In this case, Z is equal to 2 because it's a BCC. Number of atoms per unit cell for a BCC or a body-centered cube is 2. Now, A value is given to us in terms of picometer. When we convert it to centimeter, it's going to be the same power, 216 to 10 to the power minus 10 centimeter. Molar mass is also given to us 23 gram per mole. Avogadro's number is a constant. You are expected to know it by heart. It's a direct substitution to the formula. Now density is equal to, just substitute all the values that you have here. Instead of Z we have 2. Instead of M we have 23 divided by, instead of A we have 216 to 10 to the power minus 10 the whole cube into Avogadro's number. Cube it. You have to calculate the entire part and you will get your answer as 4.364346 gram per centimeter cube. Now during the calculation, the entire calculation, one place where every student can go, can get a mistake is sometimes some students forget to cube this. Please don't do that, because when you forget to cube it, your entire answer is wrong here. So please remember that A cubed should always be done in the calculation of density, only then move forward. So first thing when you substitute is calculate the cubed value and then you can move forward in this. Alright. Now let's move into the last question, which is problem number 3. Calcium crystallizes in an FCC lattice with an edge length 0.556 nanometer. So here the unit is different. Calculate the density of the crystal. So in this case, what is given to us is A value, which is in terms of nanometer. So the conversion that I gave you, use that conversion. So here, since it's nanometer, when you convert it to centimeter, it's going to be 10 to the power minus 7 centimeter. So that's why I told you, whenever you look at density problems in terms of packing efficiency, there are only 2 units that are mentioned to us. One is picometer and the other one is nanometer. Know their conversions to centimeter and you're good to go on the calculation. Alright, now Where we have molar mass is 40 is not given to us because it's clearly mentioned that the element is calcium. You are expected to know the atomic mass at least. So calcium molar mass is 40. Then Z value is 4 because here it clearly says FCC. Number of atoms per unit cell for FCC is 4. Avogadro's number is a constant. It is by hearted. So you just substitute all these values in the formula. So instead of Z we have 4. Instead of M we have 40. Divided by A cube is 0.556 10 to the power minus 7 cube. So minus 7 is for conversion from nanometer to centimeter. Cube it into its Avogadro's number. When we calculate this entire thing, your value here is going to be 1.545 gram per centimeter cube. So here we have simple substitutions to your formula where you need to calculate density. The only thing to be kept in mind is conversion from picometer to centimeter or nanometer to centimeter. That's very important. And you should know the Avogadro's number by heart. Apart from that, everything else will be mentioned in the question. Read the question properly, clearly, and then put down the given value. Only then move forward in the calculation. Please remember the end result or the unit here for density should always be gram per centimeter cube. So I hope this video is clear to all of you. In case you have any doubt, any clarifications or any suggestion, please don't hesitate to put a comment in the comment box or send a mail to the email ID mentioned in the description box below. I'll see you in another video. Thank you so much for watching the video.